Hello, I'm Channabam Kapoor. I'm going to discuss my solution to the LeetCode problem merge intervals. It's today's daily challenge in LeetCode. The problem definition is we have a bunch of intervals. An interval is indicated by starting timestamp and ending timestamp. We need to merge the overlapping intervals. That's how create new set of intervals which covers the same time, but overlapping intervals are clubbed or merged into one single interval. If you take the first example, we have four intervals in the input. The first one starts at 1 and ends at 3. The second one starts at 2, which is before the first one ends. So that's going to be overlapping with the first. So that's how the first two intervals are going to be merged to 1 to 6, right? And the third one doesn't overlap with the previous one, and fourth one doesn't overlap with the third one. So they are all disjoint. So they are going to remain as it is. So that's why the resulting set of intervals is going to be only these three, right? So let me take another example which has some more intervals, and then maybe we can come up with an approach. So I'm going to use a timeline here, and then use these intervals. So maybe the timeline starts with 0, and the first interval could be again 1 to 3. So 1 and 3 are here, and the second interval could be just like this. It could be like 2 to 6. So 2 to 6 is the second interval. Third one, I'm going to introduce one more between 4 and 5. So from 4 to 5, this is the third interval. And fourth one could be 8 to 10 as it is here. So 8 and 10. And fifth one could be another one which starts at 10 and then ends at say 11. And sixth one could be 15 to 18, right? So these are the six intervals we have. Now, what should be the expected answer? The expected answer is, see, look at this, the 1 to 3, 2 to 6 are overlapping, and that is going to create 1 to 6 anyway, and 4 to 5 within that. So these three intervals are going to be merged into single interval from 1 to 6. And 8 to 10 and 10 to 11 are also kind of overlapping. We can merge them into one single interval from 8 to 11. And 15 to 18 is going to remain as it is. So these are the three intervals we're going to have in the result, right? So what should be our approach? The approach I'm going to use is something like this. So I'll start with the result having the first interval of the input. So 1 to 3 is going to be my first interval, right? So my result is going to have 1 comma 3. So now that is the first interval we already processed. So what is the second interval in the input? So by the way, we need to sort all the intervals in the input by starting time. So that way we process them based on the starting time. If multiple intervals have the common starting point, it doesn't matter what the ending time is, right? So that's okay. So that's why I'm only sorting based on the starting time. So we have already the first interval is in the result, and look at the second interval. It starts at 2 and ends at 6. 2 is lesser than or equal to 3. That means it's overlapping with the recent interval in the result. So that's why we are going to merge, and then we change this 1 to 3 into 1 to 6, right? So that's how we process the second interval in the input. And when we look at the third interval, which is from 4 to 5, 4 is lesser than or equal to 6. Sure, it overlaps. But look at the ending time of the interval, which is 5. That is not more than 6, so it's not going to change. So we kind of merged here, but it's not going to change this 1 to 6. It is going to remain as it is. Now look at the third one, or sorry, fourth one from 8 to 10. 8 is greater than 6. That's why it is going to be a new interval, 8 to 10. And by the way, this 1 to 6 is kind of finalized. It's not going to change, right? So now look at 8 to 10. And so that's how we have 1 to 6 already here, right? And 8 to 10, when you have, that is the first interval we are going to have. And now when you look at 10 to 11, 10 is less than or equal to 10. So that means it is overlapping. So, and look at the ending time 11. 11 is greater than 10. So we are going to modify this and then make it 8 to 11, right? So that's why this interval is going to be extended to 8 to 11. And now look at the next interval, which is 15 to 18. 15 is greater than 11. That's why this interval is not going to change. So we have a new interval in the result from 15 to 18. And after that, there are no more intervals in the input. So this is the end of it. So we are going to have three intervals in the result, which is as shown here, right? 1 to 6, 8 to 11, and 15 to 18. All right. So that's the approach I'm going to use. So to start with, I'm going to sort the input. and then go over each of the intervals in the input, and then keep merging into the recent interval in the result, right? So if it is overlapping with the recent interval, we are going to merge. Otherwise, we'll add it as a new interval in the result, right? So this is the approach I'm going to use. Let me show you my code. It's kind of very compact in that sense. So I'm sorting. Look at this. I have this set of intervals here. I'm sorting based on the starting time. So I'm not really looking at even the ending time, if it is equal or what. So if it is less than, so this is the only condition I need in this case. So I'm going to sort them. So this will take big of n log n time for sorting n intervals. And then the first interval in that sorted list of intervals is going to be in the result, right, to start with. And then I go over from second interval till the end of all the intervals in the list. And every time I see that in the input, the starting or the starting timestamp of the interval, if that is greater than the recent interval's ending timestamp, then it is kind of a new interval we are going to have. So we are going to just push this new interval into the result. If it is overlapping, if it is overlapping, we may have to change the ending interval. Obviously, it's going to be merged now. We are not going to have a new interval in the result. One count is going to be less. But if this condition is true, that means the ending time of the new interval from the input, if that is greater than the ending time of the recent interval in the result, then only the ending time of the recent interval in the result is going to update. Otherwise, it doesn't have to. Otherwise, what does it mean is it is kind of totally consumed in the current interval. So that's why we need this case. We don't need the other case where it is totally consumed. And then we move on to the next interval in the input, and that's how we are going to have the result in the end, right? So this is as in that simple to code. And if you look at the whole thing, is we already know it's going to take big O of n log n time to sort. But along with that, we have only linear time in the loop here. Look at the loop; it runs for every interval in the input, and it takes constant time within that. So that's why it takes big O of n log n plus big O of n. Overall, it is big O of n log n time complexity, right? Even though after sorting, it is only linear time. All right. So yeah, if you know any other way of solving it, or if you want to learn more about interval problems, there was one problem in October LeetCoding challenge, which is remove duplicate intervals or remove covered intervals, which is here, which was on 4th of October. So take a look, and there are a few more problems on intervals in LeetCode. They are all interesting. So take a look at them. All right. So yeah, please like the video and subscribe to the channel, and thanks for watching.